enthusiasts. Welcome back to our channel where knowledge meets innovation. Are you aspiring to join the elite league of IT professionals and secure a dream job at a multinational corporation? Well, then you've come to the right place. In today's video, we are diving deep into the world of real-time ETL testing with SQL, a crucial aspect of data management and an essential skill sought after by top MNCs in recent interviews. Whether you are a fresh graduate looking to make a mark in the industry or a seasoned IT veteran aiming to stay at the cutting edge, understanding real-time ETL testing and mastering SQL is vital to your success. But we know that preparing for interviews can be challenging, especially when the competition is fierce and expectations are high. That's why we've put together this comprehensive video. Our experts have curated a list of the most frequently asked interview questions related to real-time ETL testing and SQL. We'll not only walk you through each question's theory, but also provide hands-on examples to ensure you grasp the concepts effortlessly. By the end of this video, you'll feel confident in your ability to tackle any real-time ETL testing and SQL interview question thrown your way. Not only that, but you'll also have a solid foundation to excel in real-world scenarios once you land that coveted job. Also, we will cover crucial topics like data extraction, transformation, and loading processes, the intricacies of ETL testing, real-time data validation techniques, and SQL queries for analyzing and manipulating data effectively in our upcoming videos. So, if you're ready to take your skills to the next level and embrace success in MNC interviews, don't forget to hit that like button, subscribe to our channel, and ring the notification bell so you never miss an update. Let's get ready to turbocharge your career and embark on an exciting journey into the world of real-time ETL testing with SQL. Let's dive in. All right, let's kick off with our first question. The question is, write a SQL query to get customer transaction details made through card and net banking in the last 1 hour. We'll not only provide you with the SQL query to answer this question, but also explain in detail how the query works step by step. So let's dive in. Before we dive into the solution, let's clearly understand what we need to achieve. We have a table called transaction table, and that contains various transaction details, such as transaction time and payment method. We want to retrieve all the customer transactions made through either card or net banking within the last 1 hour. Our SQL query for the current question is here. Let's run this query and see the result. Great! We now have the transaction details from the last hour. Now that we have our query written down, let's break it down step by step and understand how it works. The first part of the query focuses on the transaction time column. We want to retrieve transactions that occurred within the last hour. To achieve this, we use the systimestamp function, which gives us the current timestamp. By subtracting interval 1 hour, we go back in time and capture transactions within that 1 hour window. The second part of the query deals with the payment underscore method column. We are interested in transactions made using either card or net banking. The or operator combines these two options to ensure we get all relevant records. All right, that's all about first question and the SQL query. Now let's see the second question asked. Write a SQL query to extract 8 characters from an address column and convert it into a date. First things first, let's understand the question. We have an address column in our SQL table. Let's look at the address column in the table. And we need to extract 8 characters from this column and convert it into a date. Sounds challenging, right? But fear not, we'll break it down for you. As usual, first we write down the query and we will explain it step by step. Let's write the down query. Our SQL query is here for the second question. And run this query and see the result. Great. We got the result. Here we extracted 8 characters from an address column and converted it into a date. Now we have our SQL query and got the result. Let's break it down step by step. First, we need to extract those 8 characters from the address column. We can use the substr function in Oracle SQL, which allows us to extract a substring from a given string. In this query, we selected the substring starting from the first character and extracting 8 characters. Now we have the 8-character substring from the address column. Now that we have our 8-character substring, we can proceed with converting it to a date. But remember, before converting to a date, we must ensure that the format of the substring is compatible with the Oracle date format. Our extracted substring is in the format YOYMMDD, so we have used the _date function in Oracle SQL to convert the string into a date. In this query, we use _date to convert the extracted 8-character substring into a date with the YOYMMDD format. Now, our substring is successfully converted to a date. And there you have it. Let's see another question. And the another question they asked is, write an SQL query to select employee who is serving from last 8 years and ready to leave on the 31st of July 2023. Okay, let's understand the question. Imagine you are a human resources manager, and you need to identify employees who have been loyal to the company for a long time, but are now planning to leave on a specific date. How can we achieve this using an SQL query? Let's explore the solution step by step. To solve this problem, we will be using an Oracle SQL query. The first step is to identify the employees who have served in the company for the last 8 years. We'll do this by comparing their hire dates with today's date and selecting those who have an employment duration of 8 years. Let's write the down query. In this query, we are selecting the employee ID, employee name, and hire date from the employee's data table. The where clause filters the results to include only those employees whose hire date is equal to or greater than the date exactly 8 years ago from today, using CUSDate function. Now we need to refine our results further to only include employees who are planning to leave on the 31st of July 2023. For this, we'll use another where clause to check their planned departure date. Let's write down the another where clause query. Here is the query. Here, we add another condition to the where clause to include only those employees whose departure date is exactly the 31st of July 2023, which is represented by the TO_date function. And that's it. By combining both conditions, we have our SQL query to select employees who have served for the last 8 years and are ready to leave on the 31st of July 2023. Now, run the query and see the result. There you go. We got employees' details who are ready to leave on the 31st of July 2023. And I hope you found this SQL query explanation helpful. If you have any more questions or want to learn about other SQL topics, please let us know in the comments below. Let's jump into another ETL interview question. The another questions they asked is a theoretical one. Let's look into it. And the question is, explain about stored procedures. Okay, here's a step-by-step explanation of stored procedures with an example. Stored procedures are like custom-made functions or routines in a database. They are a set of predefined SQL statements that are stored and can be executed whenever needed. They are designed to perform specific tasks, and they make it easier to manage and reuse complex database operations. Stored procedures are commonly used in relational databases like SQL and Oracle. Let's see an example on how to create a stored procedure. Let's say we have an employees table with columns, employee_ID, first name, last name, department, and salary. We want to create a stored procedure that retrieves all employees based on department ID and display their names and salaries. Here is the query to create a stored procedure. Get department employees. This procedure retrieves employee data from the employees table for employees belonging to the department ID equals to 90 and displays their names and salaries using the dbms_output.put_line procedure. The procedure uses a cursor to fetch the data and handles exceptions if no employees are found or if any other errors occur during the execution. Let's break down it step by step. The create or replace procedure statement is used to create the getDepartment employees stored procedure. The is keyword signifies the start of the procedure's declaration section. Here, the procedure declares 3 variables to store employee data: emp_first_name, emp_last_name, and emp_salary. These variables are declared using %type to automatically match the data type of the corresponding columns in the employees table. And we have a cursor named C_employee is declared. The cursor is used to hold the result set of the query that fetches employee data for the department ID 90. The begin keyword marks the beginning of the procedural block where the actual logic of the procedure is written. The cursor C_employee is opened using the open statement, which executes the query and prepares the result set for retrieval. The loop statement is used to fetch data from the cursor into the declared variables until there are no more rows to fetch. The fetch statement retrieves the next row from the cursor and stores the values into the variables MP_first_name, EMP_last_name, and EMP_salary. The exit. When statement is used to exit the loop when there are no more rows to fetch, which is determined by the %NotFound attribute of the cursor. And the employee data is displayed using the DBMS_output, put_line procedure, showing the employee's full name and salary. So, once all the rows have been fetched, the loop ends, and the cursor is closed using the close statement to release the resources associated with it. Here, the exception block handles exceptions that may occur during the execution of the procedure. It specifically handles the no_data_found exception, which occurs when no employees are found in the IT department. It also handles any other exceptions, denoted by when others, and displays the error message using DBMS output, put line. That's it. Let's run this. There you have it. We have created a stored procedure. Now let's see how to execute this procedure. To execute the GetItDepartment employees procedure, you can use any Oracle SQL client, for example, SQL*+, SQL Developer, or SQL_CL, and follow these steps. Make sure you are connected to the Oracle database that contains the employees table. To run the procedure, simply call it using the following command. The procedure displayed the names and salaries of employees belonging to the department 90A in the employees table. If no employees are found in the department, it will show an appropriate message. That's all about stored procedures. Let's see another question. And the another question they asked is, explain the difference between clustered and non-clustered index. All right, we'll unravel the mystery behind clustered and non-clustered indexes and how they work their magic in optimizing database performance. Let's get started. Imagine you have a massive table in your database with thousands of records. Whenever you run a query to fetch specific data, the database needs to scan through all those rows to find what you need. That's time-consuming and inefficient. This is where indexes come to the rescue. An index is like a carefully organized roadmap that helps the database find information faster. We have two main types of indexes, clustered and non-clustered. Let's start with the clustered index. It's like having the table's data rows organized in a specific order, just like a well-sorted bookshelf. The rows are physically arranged based on the index key, often the primary key of the table. For an instance, think of a clustered index like a phone book that is sorted alphabetically by last names. If you want to find a person's phone number, you can quickly navigate to the approximate location based on the first letter of their last name and then easily locate their entry. In Oracle, you don't explicitly specify that an index should be clustered. Instead, the clustering behavior is determined by the storage properties of the table. When you create a table with a specific column as the primary key, Oracle will, by default, create a clustered index for that primary key column. Let's have a look at Oracle SQL query for creating a clustered index. Here's an example of creating a table with a primary key, which will create a clustered index. In this example, the employee_ID column will be the primary key, and it will have a clustered index on it. So you don't explicitly specify that an index should be clustered. Now let's talk about Non-clustered indexes. Unlike the clustered index, the data rows in the table remain unchanged. Instead, the non-clustered index creates a separate structure that includes the index key and a pointer to the actual row. Okay, for example, think of a non-clustered index like a book's index at the end. It doesn't change the order of the book's pages, but it lists specific topics along with page numbers where you can find them. It's like a quick reference guide. In Oracle, you can explicitly create a non-clustered index using the create index statement. Let's create a non-clustered index on the department column of the employees table. In this example, the IDX_department index is non-clustered, and it will speed up queries that involve searching for employees based on their department. So, how does this indexing magic improve performance? When you run a query, the database checks the index first, finding the relevant pointers to the data rows, which saves a ton of time compared to scanning the entire table. And remember, you can have only one clustered index per table, but multiple non-clustered indexes are possible. It's essential to design your indexes wisely to optimize your database's performance. All right, that's all about indexed. If you have any questions or any feedback, please mention in the comments section. Let's jump into another ETL testing question. And the next question is, what are the validations you perform as part of ETL testing? All right, let's explore the essential validations we perform as part of ETL testing that ensure the accuracy and reliability of data during the ETL process. The first validation we perform is source data verification. We need to ensure that the data extracted from the source system matches our expectations and ensure that the data extracted from the source system matches the expected data. You can use Oracle SQL queries to validate this. For example, suppose you are extracting data from an employees table in the source system. You can verify the count of records to ensure data completeness. Let's look at the SQL query. By running this query, you can validate the source data count, and next, we move on to data transformation validation. During ETL, data may undergo various transformations, and we must ensure that the transformation logic is correctly applied. Use Oracle SQL to verify the transformation logic. For example, suppose you are transforming a sales table, and one of the transformations involves converting prices to a different currency. You can verify this transformation using the SQL query like this. So using Oracle SQL, we can validate these transformations to guarantee data accuracy. Now, another important validation is data quality checks are crucial to ensure the data meets the required standards and business rules. Ensure the data meets the required quality standards and business rules. We use Oracle SQL queries to perform data quality checks. For example, check if all the customers' names are in uppercase, assuming that's a business requirement. We can use Oracle SQL queries like this to perform these checks and identify any data quality issues. And another validation is duplicate data check. Managing duplicate data is essential to maintain a clean and efficient database. Validate that duplicate data is handled correctly during the ETL process. Use Oracle SQL to identify and eliminate duplicates if necessary. For example, check for duplicate records in the orders table based on order numbers. So Oracle SQL query, we can find and eliminate duplicate records, ensuring data integrity. Let's see another validation, that is data completeness verification. Data completeness verification ensures that all expected data is loaded into the target. For example, check if all the required columns in the products table have non-null values. Oracle SQL queries help us validate if all required columns have the necessary data. Let's see another validation, that is referential integrity check. Validate that referential integrity constraints between tables are maintained during the ETL process. Use Oracle SQL to perform these checks. Example, ensure that the foreign key relationship between orders and customers is maintained. Using SQL queries like this, we can verify that the relationships between tables are maintained accurately. And another validation we have to perform is data aggregation verification. Check if data aggregations like sum, average, count is accurate after the ETL process. We use Oracle SQL to validate these aggregations. Data aggregation verification ensures that our data aggregations are accurate. For example, verify the total sales amount for each product in the sales table matches the expected sum. Using SQL, we validate the aggregated data, ensuring reliability. And the other validation is data consistency check. Data consistency checks compare data between the source and target systems. Validate that the data loaded into the target system matches the data in the source system. We use SQL to compare data between source and target. Example: compare the customers table in the source and target databases. With Oracle SQL, we identify any discrepancies, helping us maintain data consistency. And the last validation is error handling verification. Ensure that error handling and logging mechanisms are working correctly during the ETL process. Review Informatica logs and Oracle SQL queries to identify and resolve any errors. By reviewing Informatica logs and Oracle SQL queries, we can quickly identify and resolve any issues. That's all about the validations. Let's jump into another question. Alright, the another question they asked is, which table will update first on day-to-day basis in ETL flow? Is it dimension table or fact table? Okay, we will find out the answer for this. We'll demystify the question of which table gets updated first, the dimension table or the fact table in ETL. So, let's dive right in. In the data warehouse, we have two essential types of tables: dimension and fact tables. The dimension tables hold descriptive attributes like customer information, product details, or date information, while fact tables contain quantitative measures or metrics related to business transactions or events. In an ETL, extract, transform, load process, both dimension and fact tables can be updated on a day-to-day basis depending on the data sources and the business requirements. The choice of which table to update first can vary based on the specific ETL workflow and the underlying data model. Let's go through step-by-step examples for both scenarios. Let's start with the scenario where the dimension table gets updated first. Imagine a retail business. We have a product dimension table containing product IDs, names, categories, and supplier details. Every day, new products may be added, existing product details updated, or some products discontinued. Here's how it works. First, we extract the latest product data from our sources. Next, we transform the data to handle changes like updates or new product additions. Finally, we load the transformed data into the product dimension table, keeping it up to date with the latest product information. Now let's explore the scenario where the fact table gets updated first. Picture a sales fact table that tracks daily sales transactions. Each day, new sales data is generated, and we need to capture this information for analytics and reporting. In this case, we extract the latest sales transaction data. Then, we transform the data to match our data model and ensure consistency. And lastly, we load the transformed sales data into the sales fact table, adding new records for the day's transactions and updating relevant metrics. So which table gets updated first? It really depends on the business requirements and data sources. Sometimes dimension tables change daily, while other times, fact tables receive more frequent updates. Remember, both dimension and fact tables play crucial roles in creating a comprehensive and accurate data model for analytics. That's all for now. Let's jump into another question. And the other question is about schema types. Explain about schema types? Let's jump into the topic. So have you ever wondered how data is organized and structured in a data warehouse? Well, we'll break it down for you in simple terms with some real-time examples. Let's get started. In a data warehouse, a schema is like a blueprint that defines how data is organized and structured. It provides a way to store and manage data efficiently so that it can be easily accessed and analyzed. There are mainly three types of schemas commonly used in data warehousing: star schema, snowflake schema, and galaxy schema. First up, we have the star schema. Just like a star, this schema has a central fact table surrounded by dimension tables. Imagine you have a sales database. The fact table contains sales-related data like sale ID, date, customer ID, product ID, quantity, and total amount. Then, the dimension tables hold additional information about customers and products. See, the fact table links to the customers and products dimension tables. This way, we can easily analyze sales by customers or products without repeating customer and product information in every row. Let's talk about the snowflake schema, which takes the star schema a step further. In this case, we normalize the dimension tables into smaller, more granular tables. Let's take our customers for example. Instead of having a single customer's dimension table, we split it into customer underscore details for name and address and customer underscore contact for phone numbers. This helps reduce redundancy and improves data storage efficiency. In this case, the dimension tables are further normalized into multiple related tables. So the customer's dimension from the star schema is split into two tables, reducing redundancy and potentially saving storage space. However, it requires additional joins when querying data that involves both customer details and contact information. Lastly, we have the galaxy schema, also known as the constellation schema. This schema is like a combination of multiple star schemas, sharing some common dimension tables. Imagine you have another fact table for inventory data in the same database. Both the sales and inventory fact tables link to the products dimension table. This way, we avoid duplicating product information, and it's easier to maintain a clear relationship between products and sales/inventory data. So to sum it up, the star schema is simple and straightforward, while the snowflake schema reduces redundancy by normalizing dimension tables. The galaxy schema is perfect when you have multiple fact tables sharing common dimensions. And that's it, folks. Let's jump into another question. All right, let's have a look at another question they asked. Write an SQL query to delete duplicate records from a table. So let's get started and see the solution. Imagine you have a table in your Oracle database, and due to various reasons, it contains duplicate records. These duplicates might have been inadvertently inserted or generated during data migration or integration processes. Duplicates can lead to data inconsistencies and performance issues. So, it's crucial to remove them while preserving the unique and correct data. Now let's understand how we can identify the duplicate records in our Oracle table. For demonstration purposes, let's assume we have a table called policy_information with columns pol_id, cust_name, and cust_email. We want to remove the duplicate records based on the pol_id column. So here's the Oracle SQL query to delete the duplicate records from the policy_information table. Let's break down the SQL query step by step. The subquery inside the not in clause selects the min rowed for each group of duplicate records based on the customer name and customer email columns. This effectively keeps only the first occurrence of each unique combination. And the delete statement deletes all rows from the policy_information table, where the rowed is not present in the subquery result, which means it will remove all duplicate rows, leaving only the first occurrence of each unique combination intact. After executing this query, the policy information table will have no duplicate records, and only the first occurrence of each unique customer name and customer email combination will remain. Remember to back up your data before performing any deletions to prevent accidental data loss. That's how we delete duplicate records. This is not only the way we can delete duplicate records, using a CTE, common table expression to identify duplicate rows. Let's jump into the final question from the recent interview. And the final question is, write an SQL query to select highest salary employee from each department using rank functions. So, let's see the solution. Before we dive into the SQL query, let's understand the problem we're trying to solve. Imagine you have a database with a table containing employee information, including their salaries and the department they work in. Now you want to find the highest paid employee from each department. How do you achieve that with a single SQL query? Well, that's where the rank function comes to the rescue. All right, let's introduce the rank function. In SQL, the rank function assigns a unique rank or position to each row within the result set based on the specified column's value. It's crucial to understand that the rank function doesn't eliminate duplicate values. For example, if two employees have the same salary, they will receive the same rank. Now let's write the SQL query step by step. First, let's understand the syntax. In this query, columns represent the columns you want to select from the employee table. The magic happens with the rank function, where we use the over clause to partition the result set by the department column and order the salaries in descending order using order by salary desk. To break it down further, the partition by department tells the rank function to group the rows by their departments. so each department will be treated as a separate partition. Next, order by salary desk sorts the salaries in descending order within each department. Now, as the query executes, the rank function will assign ranks to each employee based on their salary. The highest salary employee in each department will have a rank of 1. Let's put this query into action. I have a sample database with an employee table containing name, salary, and department. Let's see how the query works in practice. And now let's execute our SQL query and find the highest salary employee from each department. And there you have it, folks. We've explored the power of the rank function in SQL and used it to find the highest salary employee from each department with a single query, and that's all, folks. These 10 questions were asked in recent interview by one of the MNC, and we have more sets of recent interview questions from different companies. I hope you enjoyed this video and found it helpful. If you did, please give it a thumbs up and consider subscribing to our channel for more exciting tech-related content. Don't forget to leave your questions and comments down below. Thanks for watching, and I'll see you in the next video. Happy coding!